Hi everybody, I'm Greg Fishel. Welcome to bonus weather video for this Wednesday, August 7th. And this is going to be a fairly short one. Just a couple of interesting things about tropical systems. Really is not applicable to Debbie at all because Debbie is a tropical storm and not a big hurricane. But nonetheless, these are sort of some interesting idiosyncrasies that go with tropical cyclones that I thought you might be interested in. So let's go on ahead and talk about two of those here. And here, this is my poor man's representation of a landmass, if you will. And we're going to say that this L represents a hurricane that is sitting offshore. And you've got isobars going around it. Now, isobars are rarely perfectly circular like that, but for the purposes of this argument, we will assume that they are. So the isobars are lines of equal pressure, and the wind basically blows parallel to those lines. A little bit of an inward turn because of friction, but not a lot. Now, we have the winds out here over the water where there's less friction, and they're going to blow more parallel to the isobars here, okay, than ones over land, because over land you have more friction, and that means that the wind slows down. The Coriolis force, which is the force due to the Earth's rotation, declines because it is directly proportional to the wind speed, and so the pressure gradient force then takes over, and that's the force that directs the wind from high pressure to low pressure. So you get much more crossing of the isobars over land than you do over water. So have you ever heard the story about the fact that the risk of severe weather and tornadoes is always along the right front quadrant of a tropical cyclone? Well, this is why. Because out over the water, the winds are basically blowing parallel to the isobars, and over land, they're cutting across the isobars at a steep angle. And so as a result, you get a lot of convergence going on in this area here, and that convergence, the air comes together, goes up, and this is where you tend to get some strong thunderstorms and even tornadoes. And also because of this turning of the wind that you see there, at the surface, it changes the wind direction quite a bit, but aloft, it doesn't, okay, because there's not any friction up there. And so that actually makes the wind profile more favorable, okay, for tornadoes to develop and rotating updrafts and all of that type of thing, because now you've got friction-induced wind shear, where the wind is much different at the surface than it is maybe 1,000 or 2,000 feet above the ground, and so the wind profile becomes more favorable for tornadoes as well. So those are two things that go on there that support the idea of severe weather being just to the right of where the cyclone makes landfall. And then there's something called concentric eye walls. Now, the closer the eye wall is into the storm, generally the stronger the winds are, because the winds are spiraling in toward the center. And we've talked about this whole idea of the conservation of angular momentum, where when the radius of curvature goes down, in other words, that circle shrinks, then the velocity has to go up, okay? So supposing you have an eye wall that is, 10 miles let's say 20 miles in diameter, 10 miles radius from the center. And then there are some outer bands with this tropical cyclone that start to form a new eye wall, but much, much farther out, okay? So then the air starts converging along that outer eye wall, and it robs the inner eye wall of its moisture supply. And so it starts to fall apart, okay? And so now the tropical cyclone has actually weakened a little bit because the eye is much bigger and the air is not spiraling in as close to the center as it was before. But then what will happen is that outer eye wall will start to contract, and it will get back to maybe the same place that the original eye wall was, and by that time the tropical cyclone will strengthen again and the maximum wind speeds will actually go up. So this is why especially when you get to a strong hurricane, there's going to be these oscillations in intensity due to effects like this. And the Hurricane Center is always careful to point this out in their discussions, that they said there can always be what they call eye wall replacement cycles, which is another way of describing what I've just described to you here. And because of that, the really strong storms will weaken a little bit, and somebody will think, oh, gee, that's a long-term trend, but maybe after a day it reverses and it goes right back to where it was, okay? So sometimes these short-term trends are not really revealing about the long-term trend. And, a great example of that with another factor here was Hurricane Fran back in 1996. Just before the 11 o'clock advisory, it made a little bit of a turn to the right, turned to the north instead of the northwest. And so the new revised forecast track on the 11 o'clock advisory took the system up over Rocky Mount as opposed to over Raleigh. Well, it turns out that that was only a wobble, okay? Hurricanes are like spinning tops, they wobble. And so as soon as we got past 11 o'clock, then that storm resumed its original track and came right up over the triangle area, as those of you that lived here at that time will all very well remember. And so again, short-term trends a lot of times don't tell you much about the long-term trend. And so you have to be really, really careful when evaluating what a storm is likely to do past just the next couple of hours. All right, folks, that's it for now. That's bonus weather video. I don't know what number it is. I guess 3 since it's Wednesday for this week. The next one will be coming up tomorrow, and the next daily update, both the long and the short version, coming up tomorrow as well. And you all know by now that Hurricane Debbie is not Hurricane Debbie, Tropical Storm Debbie is just about to make landfall along the South Carolina coast, and the rain chances will be increasing here as we head through the overnight period and through the day on Thursday. Right now it looks like the axis of absolute heaviest rains may be to the south and west of Raleigh, but not by a wide margin. Okay, you all have a wonderful rest of your evening, and we'll talk to you again tomorrow. See ya.